If you were to ask anyone what happened 65 million years ago, they'd probably tell you about the worst day in Earth's history. The day a 10-kilometer wide asteroid, roughly the size of Mount Everest, slammed into what's now Mexico and basically ended the world. Dinosaurs gone, pterosaurs wiped out, three-quarters of all life erased in what scientists poetically call a mass extinction event. And you'd be right to picture this as an apocalypse. If you were a dinosaur. But here's the thing, while the terrible lizards were having the absolute worst time imaginable, there was one group of animals that was basically throwing the biggest party the planet had ever seen. I'm talking about mammals, who upon witnessing the extinction of their overlords, immediately decided to get absolutely massive and take over the entire world in what can only be described as the fastest evolutionary power grab in history. And the animal that kicked off this celebration? Well, it looked like a beaver designed by someone who'd never actually seen a beaver but had heard they were pretty chunky, and decided to take that description way too literally. Now, when I say mammals exploded in size after the asteroid, you're probably picturing something like modern bears or wolves emerging from the rubble. Impressive, sure, but not exactly shocking. And you might also assume that the first mammals to capitalize on the dinosaurs' demise looked fairly normal. You know, maybe like shrews or rats that just got a bit bigger, once they didn't have to worry about being stepped on anymore. Meet Taeniolabus tauensis, which roughly translates to banded slicing tooth from Taos. And honestly, that name doesn't even begin to capture how absolutely bizarre this creature was. At first glance, this mammal looked kind of like a beaver, chunky body, probably had a decent-sized tail, measured about 100 centimeters or 3.3 feet long, which I know doesn't sound that impressive until you realize we're talking about only a few 100,000 years after the extinction event. To put that in perspective, the biggest mammal during the age of dinosaurs was about the size of a badger, maybe reaching 60 centimeters or roughly 2 feet if it was really pushing it. So Taeniolabus was already like the LeBron James of post-apocalyptic mammals, except it wasn't even close to done growing yet. This unit weighed somewhere between 30 to 60 kilograms, or about 66 to 132 pounds, making it comparable in size to a large dog or a small human teenager. And remember, this was achieved in less time than it takes for the Grand Canyon to erode by a single millimeter. Basically, evolution hit the fast-forward button and just went absolutely wild with it. Now, you might be thinking, okay, so it's a big beaver rat thing. That's cool, I guess, but how weird could it really be? And that's where you'd be very, very wrong. Because Taeniolabus wasn't just big. It was evolutionarily bizarre in ways that make modern mammals look absolutely boring by comparison. But before we get to that, we need to talk about what this thing actually was. Taeniolabus belonged to a group called multituberculates, which sounds like a plumbing problem, but was actually the most successful group of mammals that ever lived. And no, I'm not exaggerating. These guys existed for 120 million years, which for context is longer than the time between Stegosaurus and T-Rex, surviving multiple extinction events and outlasting the dinosaurs themselves. They're called multituberculates because of their teeth, which had multiple bumps or tubercles that were arranged in rows, kind of like if someone designed teeth by committee, and everyone had a different idea about what teeth should look like. Seriously? Look at a multituberculate tooth under a microscope, and it looks like a tiny mountain range made of enamel, absolutely wild. And Taeniolabus? It took this already weird tooth design and cranked it up to 11 in ways that would make modern dentists have an absolute meltdown. But here's where things get really bonkers, because despite having some of the most impressive teeth in mammalian history, Taeniolabus used them for something you'd never expect. But here's where things get weird, like really weird. So, you're probably expecting me to tell you that Taeniolabus used its impressive size and fearsome teeth to become a top predator, right? After all, with the dinosaurs gone, someone had to fill that ecological niche. And what better candidate than a rapidly evolving mammal with weird teeth and bulk to spare? Except, and I cannot stress this enough, Taeniolabus was a vegetarian. Not just any vegetarian, but a committed vegetarian. Specifically one that seemed to have a particular obsession with the toughest, most unpleasant plant material imaginable. We're talking about a creature that looked at ferns, horsetails, and woody vegetation that other animals avoided like the plague, and went, yeah, that's the good stuff right there. Here's where things get truly bonkers. Remember those weird multi-bump boneless teeth I mentioned? Well, Taniolabis took that design and absolutely cranked it to maximum overdrive. Its front teeth, the incisors, were absurdly massive, measuring up to 1.3 centimeters wide, which might not sound like much until you realize that's proportionally equivalent to a human having front teeth the size of Altoids mints. Just imagine trying to close your mouth with those bad boys jutting out. And these weren't just big teeth. They were constantly growing, kind of like rodent teeth today, except way more robust and powerful, capable of withstanding forces that would shatter normal mammalian teeth into dust. But here's the really wild part. Behind those giant incisors, Taniolabis had what can only be described as biological steak knives. Its premolars were arranged in two parallel rows that created a blade-like structure, which scientists believe functioned like a pair of industrial-strength scissors, specifically designed for slicing through tough vegetation. And I mean specifically designed. These teeth had sharp blade-like edges that could shear through plant fibers with ridiculous efficiency. Imagine if someone took a beaver's teeth, made them twice as big, added serrated edges, and then said, "What if we made this but for cutting through basically wood?" That's essentially what evolution did with Taniolabis, and honestly, it's both impressive and completely insane. Now, to understand why this is so remarkable, you need to know what the world looked like right after the asteroid hit. The Chicxulub impact didn't just kill the dinosaurs, it fundamentally transformed the entire planet's ecosystem in ways that would make modern climate change look like a minor inconvenience. The impact threw up so much debris that it blocked out the sun for years, possibly even decades, causing a nuclear winter scenario that collapsed photosynthesis across the globe. Plants died en masse, forests were reduced to ash and charcoal, and the food chain basically hit the reset button harder than it ever had before. Temperatures plummeted, acid rain fell for years, and the oceans became acidified to the point where entire marine ecosystems just ceased to exist. So here's the paradox that should make your brain hurt. Taniolabis evolved to be massive during a time when plant life was still desperately trying to recover from total devastation. What was it even eating? Well, scientists believe that these mammals specifically targeted the toughest, most resilient plants that survived the extinction, things like ferns, horsetails, and early flowering plants that could tolerate the harsh, post-apocalyptic conditions. These weren't the lush, nutritious plants that modern herbivores enjoy. No, these were survival plants, the botanical equivalent of eating cardboard and tree bark, and yet Taniolabis not only survived on this diet, but absolutely thrived, packing en masse at a rate that would make modern bodybuilders jealous. To put this in modern terms, imagine if right after a global catastrophe wiped out 75% of all food sources, humans decided to exclusively eat sawdust and somehow got absolutely jacked from it. That's essentially what Taniolabis was doing, except it actually worked because evolution is sometimes stranger than any fiction we could write. And the craziest part? All of these adaptations, the massive size, the continuously growing incisors, the blade-like premolars, the specialized gut capable of processing woody material, evolved in less than 1 million years after the extinction. That's lightning fast in evolutionary terms, like going from a Honda Civic to a monster truck in the time it takes to blink. For context, modern humans have existed for about 300,000 years, and we've barely changed physically at all. Taniolabis's lineage went from mouse-sized to beaver on steroid-sized in maybe 3 times that span, while simultaneously completely redesigning its entire feeding apparatus. That's not just impressive, that's borderline miraculous. And it doesn't stop there because we haven't even talked about the absolutely ridiculous amount of force Taniolabis could generate with those jaws. Studies of its skull morphology show that this creature had enormous jaw muscles, and I mean enormous. Proportionally larger than those of modern beavers, which are already famous for being able to chew through actual trees like they're made of wet paper. The attachment points on Taniolabis's skull for these muscles were so pronounced, so dramatically enlarged, that when paleontologists first examined them, they initially thought they were looking at pathological growths or bone disease. Nope. Turns out that was just normal anatomy for an animal that needed to generate absolutely stupid amounts of bite force. So how strong was Taniolabis's bite? Well, nobody's done a formal biomechanical study on it yet. Which honestly is a crime because I desperately want to know. But based on skull morphology, muscle attachment points, and comparisons to modern animals with similar structures, some paleontologists estimate it could have generated bite forces in the range of 500 to 800 newtons. To put that in perspective, that's roughly equivalent to a German Shepherd, which weighs about 30 to 40 kilograms and is literally bred to have a powerful bite. Except Teniolabis was potentially achieving that same force while having a body more comparable to a corgi. That's frankly terrifying when you think about it, even if it was just using that force to absolutely obliterate ferns and woody stems. This thing had the bite force of a police dog packed into the body of a pudgy beaver, and it used that power exclusively to wage war on plants. Respect. But wait, and I need you to prepare yourself for this. It gets even weirder. Because here's something that absolutely blows my mind every time I think about it. Teniolabis achieved all of this while having basically no natural predators whatsoever. None. Zero. For the first time in millions upon millions of years, mammals didn't have to worry about being eaten by something with teeth the size of bananas. The largest carnivorous mammals in the early Paleocene, we're talking the first few million years after the extinction, were about the size of house cats. Maybe, if you're being generous, a large house cat, which means that Teniolabis, at 30 to 60 kilograms, was essentially invincible. It could just waddle around the post-apocalyptic landscape eating terrible plants, and nothing could stop it. Imagine being Teniolabis. You wake up one day, all the dinosaurs are gone, and you realize you can literally do whatever you want because you're now at the absolute top of your weight class. It's the mammalian equivalent of suddenly discovering you have superpowers in a world where everyone else is still learning to walk. And here's the real kicker, the absolute wildest fact that ties this all together. Teniolabis wasn't even the only mammal doing this. Within just a few 100,000 years of the extinction, mammals were experimenting with body sizes and shapes that hadn't been possible for the previous 150 million years. And they were doing it fast. Evolution was essentially running every experiment it could think of simultaneously, throwing everything at the wall to see what would stick in this brave new world. In Teniolabis, it was leading that charge with its ridiculous teeth in complete disregard for what plants should taste like. So why does any of this matter beyond just being weird and fascinating? Well, Teniolabis and its fellow multituberculates played an absolutely crucial role in shaping the early Paleocene ecosystem in ways we're only now beginning to understand. By specializing in tough, resilient plant material that other animals couldn't or wouldn't touch, they essentially became nature's lawnmowers during a critical recovery period. Think about it. These mammals were eating plants that most other animals avoided, which meant they were inadvertently dispersing seeds, creating pathways through recovering vegetation, and basically helping kickstart the entire post-extinction ecological recovery. Recent studies have even suggested that areas with high concentrations of multituberculate fossils correspond to regions where plant diversity recovered faster, which is honestly kind of beautiful when you think about it. The weird beaver rat things with nightmare teeth were actually helping heal the planet. But here's where it gets really interesting from an evolutionary perspective, and also kind of heartbreaking. Teniolabis represents what scientists call an evolutionary dead end. Not because it wasn't successful, because it absolutely was, but because multituberculates eventually went completely extinct about 35 million years ago, leaving no living descendants whatsoever. In other words, this entire lineage of wildly successful, highly specialized mammals that survived the literal apocalypse and thrived for tens of millions of years afterwards just disappeared, vanished, gone. And we're still not entirely sure why, which honestly keeps paleontologists up at night. The leading theory is that multituberculates were eventually outcompeted by rodents, which evolved similar ecological roles but with more flexible body plans and potentially more efficient digestive systems. This actually means that somewhere around 35 million years ago, creatures that had dominated their ecological niches for over 100 million years, surviving multiple extinction events, outlasting the dinosaurs, and successfully adapting to countless environmental changes. And honestly, got beaten by squirrels and mice. It's kind of tragic when you think about it. Multituberculates were the mammalian equivalent of blockbuster video, incredibly successful for a very long time until something more efficient came along and just completely replaced them. But here's what really matters. The evolutionary explosion that produced Teniolabis also produced the ancestors of all modern placental mammals, including primates, which eventually led to us. In a very real sense, we exist because mammals like Taeniolabus paved the way by proving that large body sizes were viable in a post-dinosaur world. They were the pioneers, the first wave of mammalian megafauna, testing out body plans and ecological strategies that would influence mammalian evolution for the next 65 million years. And here's something that should genuinely make you pause. Taeniolabus' story isn't unique. Throughout Earth's history, mass extinctions have consistently been followed by rapid evolutionary radiations, where surviving lineages quickly diversify and grow to fill vacant ecological niches. The asteroid didn't just kill the dinosaurs, it created opportunity on a scale that hadn't existed for millions of years, and mammals seized that opportunity with both hands, or paws, or weird five-toed feet, depending on which lineage you're looking at. The truly mind-blowing part is the speed at which this all happened. In geological terms, going from mouse-sized insectivores hiding from dinosaurs to beaver-sized herbivores with industrial-strength teeth happened in an eye blink, less than 1 million years. Modern humans have existed for about 300,000 years, and we've barely changed physically. Taeniolabus' lineage went from zero to hero in roughly 3 times that time span, while completely redesigning their entire anatomy. That's not evolution. That's a biological revolution. So the next time you see a beaver gnawing on a tree or a squirrel hoarding nuts, take a second to appreciate that they're the evolutionary descendants of creatures that survived the literal end of the world and decided the best response was to get huge, weird, and successful. And remember that Taeniolabus, despite being wildly successful for millions of years after the extinction, eventually vanished completely, leaving no trace except fossils and the knowledge that sometimes being too specialized means you can't adapt when the world changes again. But hey, at least they got to party for a few million years while it lasted, living in a world without dinosaurs, eating the worst possible plants, and absolutely dominating their ecological niche with teeth that would make modern dentists weep. In a way, Taeniolabus' story is both inspiring and cautionary. Inspiring because it shows how quickly life can recover and adapt even after catastrophic change. Literally the worst day in Earth's history, followed by the fastest evolutionary transformation ever recorded. And cautionary because even the most successful strategies eventually fail when circumstances shift. The mammals that celebrated the apocalypse eventually got replaced by newer, more efficient models, which is just how evolution works. It's not about being the strongest or even the weirdest. It's about being adaptable enough to survive whatever comes next. And honestly, that's a lesson worth remembering, because 65 million years ago, one group's apocalypse really was another group's evolutionary opportunity. The dinosaurs got an asteroid with their name on it, and the mammals got a blank canvas to paint whatever they wanted. Taeniolabus just happened to paint with teeth the size of Altoids and a complete disregard for what constitutes good food. Thanks for watching, and remember, sometimes the worst day ever for some species is the best day ever for others. Nature's weird like that.